Hey folks, hi. This is Ambrish, and we're gonna look at Cosmos 2 reasoning. Basically, it's a world foundational model by NVIDIA, and they have been doing a lot of research and a lot of progress and innovation in the field of robotics and world foundation models and things like that. So we'll just look at what we can do to run this reasoning model. First, we have to look at what Cosmos 2 reason is. It's basically a physics common sense model. That's what they call it, but it's actually a world foundational model, meaning that it can understand logics of physics, spatial reasoning, and things from vision language models, which generally normal VLMs or LLMs cannot ever do that. Not because they cannot, but they have not been trained for that specific thing, and they don't have enough data, or I'm not sure really. But yeah, but this one can pinpoint objects and things like that. It can take multiple ways of inputs, not just like images or text or even videos and all these things. I think it might take audios, but I'm not sure. You have to check that. So they have like two different models right now, which is Cosmos Reason 2B, 2 billion parameter and 8 billion parameter. 2 billion parameter is the smaller version, which can run in a 4090 machine or a smaller machine. But 8 billion parameter, you need like a much better GPU, like at least 40 GB to run inference and 80 GB to VRAM. These are all like GPUs, 80 GB to fine tune the model or something like that. So yeah, since you saw this, and it's open source, meaning that you can use for some kind of research, but you have to like cite them and things like that. So you look at that and things. And one thing about it is fine tuned on top of Qwen 3 VL. So it would be here, and you would see it around in here. Yeah, the base model. And yeah, a lot of things going on. This is not just the only one that Cosmos, the thing NVIDIA provides. It also has like predict and transfer. Like reason they have predict and transfer. Well, transfer I think is for synthetic data generation, which we'll look at next or the few videos later, and predict is something for manipulation, like understanding what is happening or stuff like that. So yeah, so to get the access to these models for your own running in your own local environment, I would suggest you to like go ahead and like basically create a Hugging Face account and submit some terms and conditions by this model. If you go to this web page and go to access tokens, and you would see your token here. Basically, you just go and create a new token, change it to read, give it a name, and create it. I did that, and basically I did that, and I created it just 22 minutes ago. I've like using a different cloud provider. And for cloud providers, you can go for anything that you like, even Brev or AWS or whatever you want. And the easiest one I went with is Vessel, because I have few credits which I can use for now. I went ahead and created one more thing called Formal Teacher, which is what I'm using currently. And I think I'm supposed to stop this. Let me stop this lovely smile. But yeah, but that one I'm not going to look at it. I'm going to use the Formal AI. I just opened this one, and it goes to a web page. Like it basically looks something like this. And I click terminal. It would give me the web page with all these things, and I created a rep. Without anything, it would look something like this. It would say Vessel AI and give you a terminal like this. And I created one directory called testing, because I was just testing it earlier. I'm going to use the same thing. In here, I have two repos. One I think I pulled from GitHub, which was Cosmos 2 Reason, and I tried to pip install it and had some issues working with it. So I created my own script, which is inside this one. Maybe I can share it with you if you want it, but you can just Google it or even Cloud code it or whatever you want. Yeah, so the environment I created is using UVENV. So this is how we created the environment. To install UV, you have to go and do a install UV. I think there are multiple ways. You can just find how to install UV. It would do a curl call and try to install it. And once you install, you have to put in source file. Once it is done, you just create your own environment like this. Once you create it, you just have to give like a source venv bin activate. If you have any questions to ask me, I'm assuming that you would know most of these, but because it's easy to find it, but if not, you always feel free to comment. I'll try to explain as much as possible. And since we are using Hugging Face things, I'm going to use this, and I did that. And once you click enter, it will totally install the whole Hugging Face thing. And in UV pip list, you would be able to see Hugging Face once it is done, which should be around yeah, Hugging Face hub. Then once that is done, we have to do something like href auth login, and when you click enter, it would ask you to paste your token, which you would have gotten from here. Okay, when you create the token, it will show you a web page like something invalidate refresh. I'm going to show you here. It would show something like this. You're going to copy it, and let me log in again. I think it would show something like this. I'm going to paste it. You cannot see it, but it is pasted. I'm going to click enter, and I'm going to click create credential no, and permission is only red, so I'm not making writing or something to the thing. And the active token is testing, which is what we created here. So I will delete this token so you can see it. It's fine, I don't mind it. Yeah, once this is done, we have to do a pip uv pip install VLM and OpenAI. These are two things you have to install, which I already installed and I'm really running this. And yeah, you can, I think in Cosmos that they should have that how to run this with VLLM. If they don't, it's fine. It's just one Claude or Anthropic or Gemini code away from running it in your end. So you can run in this way also, which is much easier and much better, I think. Should I run this? Do I think? Yeah, I have to provide my own video and stuff, but I am gonna use a video from Cloud URL because I don't wanna. Oh, maybe I can try this. Come, why don't I try this? Yeah, for nano sample.py. I'm gonna paste it. Control X, Y, enter. It would give me the thing, and I'm gonna get the URL that I used in my script because. Oh, okay, my bad. CD Cosmos reason because I've kept my code in this one. Yeah, the URL I have used is yeah, this is the URL. You see, this is just a video of a car moving around 1, 2, 3, 4, 5, 6, 7, 8, and one person. There are 8 cars, around 8 cars, and one person somewhere in the corner. So I'm going to use this URL in the script that we did. Control X, I'm going to go back and move the script that we created to the repo that we have, because in the other script I have basically I'm running both the models to check how it would work. CD Cosmos nano sample. I'm not doing anything, I just copied this completely from oh yeah, for this I might have to install the transformers and things, which is why I didn't use this. Makes sense. But yeah, and if I try to run Python sample, it would throw some error saying that there is no transformer or something. I hope. Yeah, I have to pip install all these stuff, which would be given. Did they give that? Yeah, runtime transformer stuff. Okay, so I'm going to run my code, which is basically just running VLLM, which is this code VLLM serve. I'm serving this Cosmos Reason 2B model with which the media path in the current path and maximum length I'm giving like 16,000 tokens or 16,000 length, and videos I'm just going to do this, and reasoning stuff. And I'm running this in port 8000. This would run, and whenever you like open the new cloud environment, always check how much GPU you have left if someone is using that. So this is 0. I just started it, and this is how the VLLM starts your Cosmos thing. And I have the similar thing, but here with 8B. I have not changed anything except the utilization, the port number, and this name of the thing. And since I have access to it from Hugging Face, which I like submitted some terms and condition, it gave me access to directly get it from there, or else it would generally will not let me do stuff like this. I'll run my code, which was python infer.py. Okay, it's not running because it didn't say application has started yet. It has to wait. Yeah, now it has said application has started yet. It should still throw an error because I have wrote my script in such a way that the code tests both 8B and 2B at the same time, but 8B I have not started yet. But I just want to see how it would work. Yeah, 2B model it worked at port 8000. I think it's going and checking in, but 2B model is not that great, I would say. Yeah, 2B model cars traveling around widening lens something might ordinate sparse space station and stuff. 8B it is failing. Okay, at 2B, yeah, I have to start running 8B as well. So let's run 8B. It's gonna take some time because it has to download this Cosmos Reason to 8B model. So it's gonna take some time because I think it's around 16 to 17 GB in length. So this is how the first run will take some time. Second run might be a bit quicker. In the meantime, let's try to debug the other one that we saw, the sample one. So they have torch and transformers. Let's check what it would need. Pep freeze. Rec.text. Oh, that's a lot of things. I don't know this much. I'm gonna just check Google. Just gonna type this and I hope someone will give me something to run this. Oh, this is the other website I said. So build.nvidia.com, and here you can actually see some of the outputs, inputs. You can log in and check their models and GPUs and whatever things they have. This is pretty good, but I'm not used to it running directly like this. Oh, it's already running, so nice. So generally it would take a lot of GPU to test it, but I think it's better to test with your own local environment so that you can develop your own stuff. Otherwise, I would reasoning complete. Yes. Saying how it is doing, and the response is given like opening scene, number of scenes, it's describing what it has saw till all the scenes. Interesting. Yeah, so why I was here. Let's check if this has started. Thrown error. I thought it had more space. How is 8,000, 7,000 being used? Okay, that's surprising. Give me 1 second, let me just come back. So I think I didn't give this GPU utilization as 0.45, so this one model took the whole GPU. That is what I'm assuming has happened. So I've changed this and I've asked it to like only use 45% of the GPU. So if I look, it still don't think it should use that much. So I'm going to give it some time so that it can run. And maybe they both are running the same time, so it's taking more longer stuff. So let's check again. NVIDIA SMI. This should be your best command to use forever, because this would show you how much GPU you're using. So cool. I'm going to run this again with 45%. The other 8B. We have still around like 80 minus 37 should be around like 43 GB GPU left. So I'm going to run this again. Let me try pip and it's all there, but why this is not working? Oh, I think that one would put another instance of the inference which would fail, which is why that is failing, I think. So let's wait for some time. Then let's run this code, the infer code that I had, which would check both Cosmos 2B and 8B together at the same time. Once we are done with that, let's try to debug sample.py, which we got from the, what do you say, the Cosmos Hugging Face webpage. Because I think when we ran all the three, they all got like, oh, this one worked. Nice. So we have 8B parameter running here and the 2B parameter running here. So we're gonna run infer. Hope it runs well. So model 2B is served at 8000, which was same. Cars along something something. Model 8B is at 8001. So white sedan. This is the answer. So 2B, if you see car travel around something something, very less stuff. Okay, if you see compare 2B and 8B, it was the same question, no big difference. It was similar question. I'm going to show you the code as well. Yeah, it is the same question. Describe what is happening in the video in English. Do mention English, because if the model is smaller, it generally tends to go to a different language. I've had like Vietnamese, Mongolian, Russian, and Korean languages being printed out in my reasoning model. So you don't want that happening. Same question, two different same model fine tuning, but with different sizes. So the bigger size is giving you better answers. That is what is happening. That's it. So feel free to use this, or you can go and like do the other one as well. So let's check Gemini, or we can just type the same error that we got in our previous things. I'm gonna stop both of them because I have showed you both the things that I wanted to show you. Now feel free to drop off or like go do something else, but if you want to stick, it's up to you. I'm not gonna like say anything. Now let's like check the sample one, if it can pull it. No, let's check why this exactly is happening. Oh, they want us to install accelerate. Okay, let's try this. So I gave it the same thing, no difference, just the same URL. Kind of didn't change the question though. Keeps asking a lot of things. I know I can use Cloud Code or something else like that, but I generally prefer to use coding when I have to learn stuff, because it's much easier for me to understand what's happening. In case if I use Cloud Code, I would never ever see this. I would never ever know that these are the things that are happening. So yeah, so these two packages were required for running us the Cosmos 2B model directly from the sample. And yeah, let's see if it works. And I didn't actually check what the question or query was from Cosmos 2B sample. Cosmos 2B